In this section, we're talking about ratios and rates, and we're going to look at writing ratios as fractions and then finding unit ratios, and then writing rates as fractions and finding unit rates. You'll see that rates are the same thing as a fraction, except that they have units in them. And then we're going to compute unit pricing so that we can compare the prices of different things. All right, so we're going to look at writing ratios as fractions first. So we've got 3 apples here, and we've got 6 bananas. So a ratio is just a comparison of 2 different quantities of things, of 2 different things. And there are 3 different common ways to write a ratio. So in a sentence, we use the word 2. So the ratio of apples to bananas is 3 to 6. And using a colon, you would say the ratio of apples to bananas is 3 and a colon, that means 2, when we still say 2, 3 to 6. And the last way is as a fraction, 3 to 6. And then we would simplify it. If it's a fraction, we simplify it to, in this case, 1 to 2. We don't usually do that with a colon. A colon usually has the raw numbers, and also with words. We just use the raw numbers. So the first example, we are being asked to write each ratio as a fraction in simplest form. So there's really not much new here except to take the sentence and turn it into a fraction. And from there, we just need to reduce. So, and I'm going to do this the long way, just because I saw some people were starting to get confused by reducing by taking a shortcut. So both of these have a 2 in them. So I'm going to say 2 times 5 and 2 times 12. And the 2's are then going to become 1. 2 divided by 2 is just 1. So we end up with 5/12. So 5/12 is the final answer on that one. So it's a ratio of 5 to 12, which you could also write as 5 to 12. But in this case, they're asking us for a fraction. All right. B, we've got 6 1/2. And this one's really weird, and it breaks all the rules about writing a fraction, but 6 1/2 to 1 2/3. So we've got a fraction and a fraction, which really is not legal at all. So anyway, you want to turn this into an improper fraction first. So the top one is going to be 13/2, and the bottom one is going to be 5/3. All right, so the next thing we need to think about is the fact that this bar right here is a division bar. Okay, so that's just division. And so we're going to say, well, this becomes 13/2, that's the numerator, divided by 5/3, the thing on the bottom. The numerator divided by the denominator. All right, so now then remember that division of a fraction means multiplication of its reciprocal. So we're going to say 13/2 times, and then we're going to flip this over and say 3/5. That's the reciprocal of 5/3 is 3/5. All right, so now I don't see anything that divides out or cancels. 13 is prime, everything else is prime, nothing divides out. So we end up with 39 on top and 10 on the bottom. And we don't turn it to a mixed number because remember this is a ratio, so it's 39 to 10. All right, the last one is 2.5 to 6.25. All right, so one thing you want to remember with these kind of things, and these are fairly unique, when you don't ever want to have a decimal in a fraction. That's just not how you do fractions, kind of like having a fraction in a fraction. So in order to get rid of the fraction, the decimal here, because this is to the hundredths place right here, we want to multiply times 100 over 100. Okay, when we do that, 2.5 times 100 is 250. Move the decimal place over 2 places, so we're going to take it 1, 2, and make it 250. This one's the same thing, times 100 means move it to the right 2 places, so we get 625. And now we need to reduce it. So both of these, I happen to know, have 125 in common. So this one is 2 times 125, and this one is 5 times 125. And if you'd said 5 or 25, you would have just kind of had to keep going until everything is reduced out of it and you're left with 2 over 5 because the 125s cancel out. Okay? So 2 to 5, that's the ratio. Now it's time for you to try it. Write each of these ratios as a fraction in simplest form, and each one of these has an example that we just did. So the answers are here, and I just wanted to point out a few things. The first one's fairly straightforward. Just divide out of 5. The next one, don't forget that the division sign between the two fractions, you can write it as division, and then you multiply the reciprocal. And then when I got over here, I saw that there was a 3 in 12 and a 3 in 27, so I broke those apart and took the 3's and divided them out. And I'm left with 16 over 45. The last one, I just wanted to show you that if you miss what it's divisible by, this was divisible by, I don't even know, 25 times 7, whatever that is, 175. And I missed that, so I just wanted to show you that I missed it, and it's no big deal. You get 21 over 14. You just have to think about that and say, all right, well, they're both divisible by 3 still, so 3 times 7 and 2 times, I'm sorry, they're both divisible by 7 still. So 3 times 7 and 2 times 7, the 7's divide out, and you get 3 over 2. So I factored 2 times before I got all the way down to the reduced form of 3/2. So 5.25 to 3.5 is 3 to 2. So remember, this isn't just a fraction, it means 3 to 2, which we could write as 3 to 2, or say 3 to 2. But the answer, the question asked us to do it as a fraction. Okay, I'm going to give you just a moment to read this problem. Okay, so this is about the number of state names starting with a vowel to the number of state names starting with a consonant. Okay, so think about what that means. So these kind of questions that you're going to see in MyLab, you really need to read them carefully. And I can't write a straight line that long. So then the other half of it is the number of states, state names starting with, and I'm just going to, just to shorten this up a little bit, I'm going to say state names starting with a consonant. Okay, so it says 12 start with a vowel. We have 50 states, so that means 38 of them must start with a consonant. That's 50 minus 12. Okay, so we're going to reduce this because they're both divisible by 2, so I get 2 times 6, and I get 2 times 19. The 2's are going to divide out, and I get 6 to 19. So the ratio of states starting with a vowel to those starting with a consonant are 6 to 19. This next one is for you to try, so give it a shot and then come back and see what the answer is. Okay, so here's how you do this one. You've got the number of winning to the number of losing. So that's what they asked us to do, right? The ratio of the number of winning to the number of losing. So read it carefully. So you get 15 over 1,000 minus 15, so 15 over 985. Both are divisible by 5, so I factored out and canceled out a 5, and I get 3 over 197, or 3 to 197. All right. Okay, so now we're going to look at finding unit ratios. A unit ratio is a ratio expressed as a fraction with a denominator of 1. So, for instance, you have a school that has 1,632 students and 136 teachers. So instead of saying the ratio is 1632 to 136, you change it by reducing it to 12 to 1. So we reduce it so that the bottom is a 1, and that way we can compare different unit ratios for different things and see which one's better, basically. So to find a unit ratio, you're going to divide the top by the bottom, or the denominator into the numerator. All right, so let's look at an example. While researching local schools, a student found that the student-to-instructor ratio at State College is 9:45 to 30. And at the community college is this other ratio here. So we're going to find the unit ratio for each school so that we can compare them. Let's give ourselves a little space here. So we're going to say, all right, well, State College and community college. Okay, so community and state. So always make sure and kind of lay things out so that you can keep track of everything. The state college was a 945 to 30 ratio, and the community college was 2145 students to 150 instructors. Okay, so always do it in the same order, so the students are on top, the instructors are on the bottom. Now all you're going to do really is you're going to divide the top by the bottom in a calculator. So you don't have to go through reduction if you don't want to, because you're trying to get to a 1 on the bottom. So you're just going to take 945 divided by 30, and you're going to get 31.5 to 1, or to 1. I'm going to put it like that first. So 31.5 to 1, because remember, if you divide 945 by 30, you get 31.5. If you divide 30 by 30, you get 1. So that's how that turns out. So what this means is a 31.5 to 1 ratio of teachers to students. All right, and then this one we're going to get 2145 divided by 150 is 14.3 to 1 ratio. So this one has a 14.3 to 1 ratio. So I'm going to fix this so we can actually read it. So think about what this means. If you're looking for a school with more teachers to give you more attention, which one of these would you choose? So the community college has a much lower student to teacher ratio. That means there's less students for every teacher. So now we're looking at writing rates as fractions. A rate is a ratio that's used to compare different kinds of quantities. Quantities basically means we have units on things. So we need to have units showing, and that's never really clear in the book when they talk about these. But when you're talking about a rate, you're talking about something per something. Okay, so we use the word per usually. So in this one we would say, well, if we traveled 300 miles in 6 hours, that means we would go 300 miles per 6 hours. And if you made $200 in 8 hours, you would make $200, dollars goes over here, which is kind of weird, in 8 hours, okay, per 8 hours. And then we would reduce that and do some other stuff later, which we'll do soon. All right, so let's look at just writing these rates as fractions in simplest form. So a person, I don't love this first example, a person eats 8 hot dogs in 60 seconds. It sounds a little gross, but anyway, we've got 8 hot dogs in 60 seconds. Okay, so notice we put the unit in because it wouldn't mean anything without it. So now we're going to reduce this. We've got 2 times 4 on top, and we've got 2 times, sorry, not 2 times 4, we've got 15 times 4. And if we just said 2, we would have had to reduce one more time. So the 4's are going to divide out, and we get 2 hot dogs per every 15 seconds. Okay? All right, I'm going to do the other one over here so we have a little space. So B is a person earns $72 in 9 hours. So we've got $72 per 9 hours. So 72 is just 8 times 9 over 9. So the 9's divide out, and we get $8 per 1 hour. Okay, so $8 per hour. Now you try these next two. They're really similar to the ones I just did, and then come back and take a look at the answers. Okay, so you're going to take the 2,000 and put it on the top, 24 hours on the bottom, and you end up, after reducing it, to $250 per every 3 hours. A soft drink, after reducing it, you learn that it has 15 calories per ounce, per 1 ounce. A unit rate is similar to a unit ratio, and it is a rate expressed as a fraction with a denominator of 1. We usually use the word per. Unit rates are found the same way unit ratios because they are also a ratio. They just have units now. So we add the units to tell what we're measuring. So to find a unit rate, divide the denominator into the numerator, or in other words, divide the numerator by the denominator. All right, so we're going to write each rate as a unit rate. So let's move this down, and the first one is $580 in 40 hours, or per 40 hours. So remember not to leave the units off now. So you don't need to do any reducing here. Just use a calculator, divide 580 by 40, and you're going to get that this is $14.50. And you know what to go to. You go to the hundredths place because it's money. So that's the big clue, per hour. Okay, so $14.50 per hour. All right. B, a person runs a 110-meter hurdle race in 16 seconds. So what's their unit rate? In other words, how many meters do they go per second? That's really all we're looking at here, but we want to keep the unit on. So 16 seconds on the bottom. So 110 divided by 16, you just put it in your calculator and you get 6.875 meters per second, or meters per 1 second, but we usually just say meters per second. All right, so now it's your turn. So give this a shot, write each one as a unit rate, and come back in just a moment to see what the answers are. Okay, so the person's heart beats 198 beats per 3 minutes, so that gives us 66 beats per minute. A car travels 121.5 miles with 5 gallons, and so we get 24.3 miles per gallon. So this all leads to doing things like computing unit pricing. So unit pricing is the best way to compare prices of different sizes of items. So if you're ever in the grocery store and you're trying to compare the prices of 2 different packages of things, often the grocery store does the math for you, but if they don't, this is how you do it. So the unit price is given by the product price divided by the units, the number of units. So I'll give you an example of that. So we want to see which one is the better buy. So we've got one of them that's $3.58 per 16 ounces. And we've got one that is $2.68 for 12 ounces. So at first glance, the second one looks better. But when you divide it out, you get that this one is 21.21 or 21 cents per ounce. So 0.21 of a dollar is 21 cents. And the other one is 0.22 dollars per ounce, or 22 cents per ounce. So that means that this one is a better deal. Okay, so now you give it a try, determine which one is the better buy of these two, and come back and take a look at the answer. So this one turns out really close. If you're only going to buy one bottle, they both come out to 7 cents per ounce. So it's not that big of a difference. If you're going to buy 1 million bottles and you were going to sell them and you were a big chain store, you might want to consider the difference in price. So anyway, they're about the same, but the 24 ounce is a little bit better. Okay, thanks for watching.